So let's take the first element of computational thinking, which is decomposition. And as its name suggests, it is about breaking the bigger complex problem into small pieces. So let's say you're preparing for an outdoor holiday trip with your family. On one hand, it is an affair of joy, but on the other hand, it is also a huge task to accomplish. And you would need to arrange a list of things for such a trip. It may even look like a gigantic challenge to manage. However, if you break the task down into smaller subtasks like fixing itinerary, luggage packing, booking a hotel, fixing a visa, getting the car rentals or the flights, it can really become simpler to solve each one of the subtasks. Decomposing the entire problem of organizing a trip into smaller pieces will not only be helpful to solve the problem so that it looks in smaller pieces, but it will also help you to solve in an entirely different way. Now, you can distribute all of these tasks in 3 manners. Now, you can choose to complete these subtasks one at a time or in parallel, or you even ask a friend or a relative to help you on one or more of the subtasks. So, irrespective of the option you choose out of sequencing, multitasking, or offloading, decomposition works in every case. And I wish you a happy trip. Decomposition in computer science, also known as factoring, is about breaking a complex problem or system into smaller parts that are easier to conceive, understand, program, and maintain. Decomposition helps us solve complex problems and manage large projects. So let's say you're trying to teach a similar skill to your 8-year-old kid. So let's say you want your 8-year-old daughter or son to make breakfast for themselves. For her or him, it would be a very large project. And if she understands the decomposition, she will decompose the problem into smaller tasks, maybe like making a toast or making a hot chocolate. And if we want to further decompose it, so we can even give them the steps to make the toast or to make the hot chocolate. So she may even further decompose it like slice a bread, toast the bread, butter the toast and add the jam maybe. And on the other hand, for the hot chocolate, it can be like boil the milk or add the chocolate, pour it into a mug or something in similar fashion. Now when the kids are taught on these things, they can be very useful to work in teams, because with this kind of decomposition, they can work in a team and actually solve the larger problems. You can even start teaching this element to kids as young as 3, 4 years or 5 years, where let's say you have a messy room and you want them to clean it, and they might not understand it in the beginning. But if you decompose it in the smaller tasks and ask them, let's say, place the clothes into almirah, or place the shoes in the shoe rack, or place the toys in the toy rack. By just decomposing this big problem into these 3 things, their room will be looking much clearer, and they will even understand what is a clear room or clean room, isn't it? Now when you are teaching the decomposition to young kids, you should notice 2 key things. First is that the decomposition should be decided by young kids only, not you. So whoever you are giving these tasks to, they should create the subtask. That is the first thing. So you are just a facilitator. And second thing is, it is also very important that the decomposition should happen in such a way that all the broken pieces or subtasks can be solved individually and later can be added together to build the complete solution for the problem. This concept is also known as decomposition paradigm, which is eventually a strategy to optimize the modularity of the solution with its maintainability. Imagine your kid is going to help you in cleaning the kitchen today, and one of your subtasks says, remove the vegetables from the dishes and throw it in the dustbin. And you later realize that a dish on the shelf did have the raw vegetables that your kid may have also thrown in the dustbin. So to maintain the modularity, the decomposition subtask must have been something like, remove the vegetables from the dishes in the sink and throw it in the dustbin. And in this fashion, you may help the young kids to learn the first element of computational thinking, that is decomposition. In our next chapter, we'll try to learn about the second element. Until then, thank you.